We introduce Structured 3D Features, or S3Fs, a novel feature representation for 3D human reconstruction. S3Fs allow a single model to perform a number of tasks. From a single image, our model performs 3D reconstruction, including albedo and shading, novel view synthesis, 3D human relighting, avatar animation, and even 3D virtual try-on. This is all done without post-processing, using just one monocular input image. Let's see how our model works. Starting from a single image, we first extract image features using the feature extractor network G. This is similar to pixel-aligned features used by previous methods. However, there is no straightforward way to manipulate them for downstream tasks, such as reposing. In our pipeline, we first estimate 3D body pose and shape in the form of a parametric body model. We then sample 3D points on the body surface and pull per point features from the image feature map. The points only roughly approximate the true 3D geometry, so we let the network move them freely to discover optimal 3D feature locations. Finally, we pull new features based on the updated locations, obtaining our proposed structured 3D features. The final points better cover the full body geometry, including hair or loose clothing. Further, and in contrast to previous representations, S3Fs carry over semantic information from the body model and can be manipulated in 3D. This is key for various applications including animation or 3D virtual try-on. The structure of the scene is implicitly represented in the S3Fs and can be extracted using marching cubes. Given an input point, we aggregate S3Fs using a transformer architecture and obtain its sign distance and albedo. We model scene illumination by predicting a latent illumination code from the bottleneck of the feature extractor network, allowing us to illuminate the 3D reconstruction. Here, we show our 3D reconstructions next to the images used as input. We compare this approach to Icon, shown in the bottom right. Icon is the previous state-of-the-art method in the task of monocular 3D human reconstruction, and can also take unconstrained body poses. Thanks to our pooling of features and body point displacement, our approach is able to cover loose clothing better and is more robust to challenging body poses, while not only recovering geometry but also albedo and shading. We next focus on our results on color estimation, and here show our shaded reconstructions. We compare our approach against Forum, a recent method that also performs monocular 3D human reconstruction, recovering albedo and shading. Our method leads to more accurate shading estimations that are more consistent with the input images and is not significantly affected when tackling more challenging body poses or images in the wild. The estimation of albedo and the composition of the scene illumination enables relighting our reconstructions. This is important for 3D human compositing applications and realistically placing 3D humans in novel scenes. Here we show different examples being relighted consistently with a common scene illumination. The proposed representation relies on 3D points with semantic information, enabling different kinds of applications. For instance, we here repose the points and their features to new body poses using linear blend skinning, leading to avatar animation. The structured 3D features carry semantic information and enable some tasks like virtual try-on. For example, for a given input image that we want to edit, we first extract S3Fs. We do the same for a source image that might contain the target clothing, ending up with a pair of structured 3D features. Now, given the segmentation mask of a target piece of clothing we want to edit, like upper body clothing in this case, we can easily find the target features that belong to it and combine the S3Fs from both images. By doing this, we can obtain the edited reconstruction showing the original person wearing the source clothing. We now show results on virtual try-on of upper body clothing by interpolating S3Fs smoothly between each garment. This leads to smooth cloth texture interpolations even between examples that have significant differences of style, viewpoint, or body poses and shapes. Note that this process takes only a single image of the target person and another single image of the piece of clothing, and requires no additional post-processing. Moreover, each piece of clothing is relighted with the illumination of the person's scene, as shown more clearly in the bottom left example. Thanks for watching.